I'm Yukan. The topic of our presentation is about research and forecast the impact of Chinese import restriction on Australian coal on thermal coal price in China. This is what we are going to cover in today. And moving on to the introduction. And as China is the Australia largest trading partner and they mainly import iron ore, liquefied natural gas, and coal from Australia. In recent years, Australia has been hit hard by the deterioration in relationship between China and Australia, with China increased tariff and import restriction on Australia export goods. For example, since March 2021, custom clearance procedures for Australian thermal coal have been adjusted at many Chinese ports, resulting in extended clearance time for up to 60 days. And our topic today is examining the change in Chinese thermal coal price following the restriction on Australian coal import, and to make forecasts for Chinese thermal coal price over the next 2 to 3 years. And moving on to the literature review. And our presentation mainly examines three articles. The first article suggests that a country's economic dependence on its trade with other countries often expressed in terms of trade value and share. They propose a better dynamic framework, Global Trade Analysis Project (MVH) model for assessing vulnerability to cohesive trade instrument. And the second paper, the author highlight the importance of coal to China energy supply and consumption using time series analysis. The article found that Chinese coal price and Australian BJ stream coal price as an indicator of international market price are found to be highly correlated with their price fluctuation, while crude oil, QHD, and global crude oil price are also correlated. And in the third paper, they present an exploration of coal pricing in China, analyzing what is the actual impact of price policy on coal price fluctuation, and how can forward-looking pricing policy can be made.
Okay, thank you, Yukang. Let's move to the data selection part. We choose data from Chinese.com for the daily closure price of Shanxi Premium Thermal Coal Q5500 at Qinhuangdao Port, China from January 2nd, 2019 to May 13, 2022 for a total of 803 data points. In our topic, Qinhuangdao coal price are used as our indicator of coal prices. Furthermore, Qinhuangdao is China's largest coal shipping port, accounting for more than 30% of Chinese coal shipment. As a result, Qinhuangdao coal prices are frequently regarded as the most reliable indicator of coal prices in China. The data beginning in 2019 was chosen because up until that point, Chinese coal prices were not particularly volatile or informative. In addition, the topic of our presentation is to examine the changes in domestic coal price in China following China's restriction on Australia coal imports in 2019. So using data from 2019 to present is more formative and useful. In conclusion, we choose 2019 data as our sampled data.
Hello everyone, I'm Xuan Wang. I will introduce part 3, test for structural change. There are 4 steps in this part. Step 1 is test for stationary. Step 2, choose a particular range of breakpoint. Step 3, test whether it really exists a breakpoint. Test 4, we will make a summary in this part. In the step 1, we use augmented decay test. The lag order we select is 9, and this is the weight-test model type. The H0 is that phi 1 equal to 1, H1 is that phi 1 less than 1. Because the p-value is greater than 5%, we cannot reject H0, since the original data is not stationary. After that, we make a difference, and we still select the like order is 9. We find the p-value is 0.01. It is less than 5%. We can reject H0, since it is a stationary now, and we can conduct a Riemann model to fit it. Based on ACF and PACF plot, we can find it is a Riemann 1010 model. And delta x means the log returns after one difference, and this is that model. After that, the step 2, we will choose the potential breakpoint, because Chinese government started restricting imports of Australia cereal coal in November 2020, and considering the long trading cycle of the bulk goods, we think the breakpoint exists from 2020 December to 2021 January. Then we will test whether it really exists a breakpoint. We use SE test. The H0 is that there is no structural breakpoint, and H1 is that there is the structural breakpoint. According to the p-value, we can find the p-value is less than 4%, so we can reject the H0, and there is a really structural breakpoint. After that, we will find the correct date that happen breakpoint. By using R code, we found there are 2 breakpoint date. They are number 481 data and number 608 data, and this is a state respectively. Finally, compare with potential breakpoints that are calculated, and we found that it really exists a breakpoint in 2020 December 9th. It means the Chinese import restriction on Australian thermal coal has an effect on changing Chinese thermal coal price. The next part, I will introduce my mate.
Hello everyone, my name is Guangqi Huang. Let's move to part 4, ARIMA modeling and VAR modeling. To do the ARIMA modeling, we need to identify the best legs and make sure the model's residuals are stationary. The commodity price data doesn't look like a stationary process. By doing first difference, the price data ECF values fall below the confidence interval, so we conclude the first difference is affected to remove all the autocorrelation. Also, since the left-hand side PACF values cut off at leg 10, we can try setting the P legs at equals to 10. We conduct the multiple ADF tests on the 2 commodities price data. The commodities price data are not stationary as the table shows, but both the first difference data are stationary, because we have strong evidence to reject the null hypothesis of unit roots. To do further prediction, we can use the first difference or daily return data instead of price data. As we said before, we can only simulate the first difference data and apply P less equal to 10. As the table shows, we generate multiple AIC values, and we aim to pick up the ARIMA model with the smallest AIC values. At the end, we pick up the 3 ARIMA models highlighted by red circle. The John Boss test statistic showed the residual series are stationary, so we can say the residuals are following the independent distribution. The AIC plot shows the first difference is affected in process the autocorrelation. At the end, we run the LN test on the residuals, but we have very strong evidence to say there exists arch effect. So we conclude that the ARIMA model's residuals are heteroscedastic, which are against the John Boss test result. Therefore, we need to further investigate for a better model using GACH. This part will be illustrated later by my teammates. In the part 4 second session, we investigate the co-integration relationship between the two commodities price. We expected they have certain correlation in long term, as they are highly substitute for each other. The daily return is stationary, which is being proven. Then we need to search for the smallest AIC values to determine which of the multiple legs can be the best model for the given data. We then identify the optimal legs number is 5. So we stimulate the VAR5 model as below. Let's try and interpret the co-integration test result. We have strong evidence to say there exists co-integration between the commodities daily return. We then visualize the linear combination. This looks like a stationary process, but we still need to conduct an ADF test on the linear combination. We have strong evidence to say the linear combination is stationary. Therefore, we conduct the VAR5 model can remove the residual autocorrelations. Finally, the Granger causality test use F statistics to do the joint hypothesis test on the coefficients. The result shows the commodity daily return Granger cause each other, which means the commodities daily return have co-integration relationship. Besides that, we can assume the VAR model is stationary as all the coefficients are not greater than 1. Thank you.
For part 5, Ziang and me working together on the gauge model and the forecasting part. So now Ziang will introduce your more detailed information.
Okay, we use AutoOrima to automatically generate a lex that is also optimal for ORIMA model, which is ORIMA 214 model. Then there are 4 gauge models derived from ORIMA 214 model. They are gauge 11, gauge 12, gauge 21, and gauge 22 model. By comparing the AIC size of 4 model of these 4 gauge models, the best one can be selected. From the data, we can see the AIC of these 4 gauge models are 11.01, 11.02, 11.03, and 11.02 respectively. Therefore, we can see the data. The gauge 11 model is the best one because its AIC is the smallest. Let's move to standardized residual tests. We have done 4 tests for this model. The first 2 tests are Jacobera text and Shapiro-Weld text. The long hypothesis of these first 2 texts is that the residual sequences is normal distribution. We can see the p-values of these 2 texts both are 0. It means we reject the long hypothesis at any significance level. The residual sequence is not normal distribution. Next.
Okay, the next 2 tests are L-Dream box test and LM arch test. The null hypothesis of these 2 tests is that the sequence is one nose. We can see the p-values are pretty small, less than 0.1, which means that we reject the null hypothesis at any significant level. So the residual sequence has anti-correlation and isn't wide nose.
Okay, next is gauge model for casting. I fit these 4 gauge models respectively to construct out of sample prediction data with a prediction length of 120 trading days. The prediction results are represented by the following pictures. These 2 pictures are, the first 2 pictures are gauge 10 and gauge 11 model. And the next 2 pictures are gauge 12 and gauge 22 model. After looking at the pictures, the results show that 2 high order tends to overestimate the performance of volatility, and gauge 10 model can better predict the fluctuation of logarithmic return. For these 4 gauge models, I calculate the square sum of this residual between the fitted value and the actual value. We divide the data set into train set and test set. The train set is the first 684 observations, and the test set is the remaining observations. The performance of the 4 model is as follows. We can see the graph. The results show the gauge 10 model has the smallest sum of squares of residual. So 10 is 10 order is optimal model order, while Gauge 10 model is optimal Gauge model. Thanks.
Okay, let's move on discussion part. Thank you, Ziyang. Thank you, Kitty. Let's move to the next stage, which is discussion part. Let's talk about the disadvantages of our model. First of all, there are many factors that affect the volatility of the coal price, but our model only discusses one of them. Although our model can play a certain forecasting effect, due to there are too many influencing factors, our model cannot completely predict the price of Chinese coal if it has been influenced by other factors that we didn't consider. Secondly, due to the impact of the epidemic and war nowadays, the price of energy and commodities have generally risen. Since China is a socialist country, its economy is subject to macro control. Government intervention may cause unpredictable changes in the markets. Therefore, our model cannot effectively predict the market trend. The last part is the conclusion part. In part 2, we see that there is a structural breakpoint. In 2020, February 9th, it means that the Chinese import restriction on Australia thermal coal has an effect on Chinese thermal coal price. In part 3, firstly, we studied ARIMA modeling. According to the residual diagnosis, the residual of ARIMA model are white noise. Although arch effect test, through this test, we find that the ARIMA model has arch effect, which refers to the heteroscedasticity. Secondly, we studied VAR modeling. We found that the optimal lag operator for VAR model is lag 5, and there is granular causality between commodities' daily return rate. In the fourth part, we do our further research using Gauge model. It suggested that the Gauge 10 is the optimal forecast model. It can do better prediction of the fluctuation of logarithmic return. It also has the smallest sum of square of residuals. Thank you. That is all of our presentation.